Most Krill nodes do one small fixed job when something they watch changes. If you need a node to do custom complex work, that's what a Lambda is. Your Python running right on the swarm. Let me show you why you'd reach for one. Here's a Krill server on a Raspberry Pi. Nothing running on it yet. Everything we add is just a node. Krill already has a calculator. It takes the current value of one or more data sources and runs it through a simple formula: add, subtract, multiply, divide. Open it up. And there's the formula, a keypad and arithmetic on alive values. Great for a unit conversion, a scale factor, an offset. But here we want more than the calculator can handle. We're going to compute a wet bulb temperature, and that takes two readings at once. Temperature and humidity run through some real math beyond the calculator's capabilities. So we set the calculator aside and reach for something with a whole programming language behind it. First, the two readings the script needs. Humidity, a data point sitting at 76%. And temperature, 85 degrees Fahrenheit. Now the Lambda. We point it at a Python script kept on the Krill server, wetbulb.py, and wire both sensors straight into it as its inputs. Watch the arcs connect, temperature and humidity feeding the script. It's invoked by its sources, so the moment either reading changes, it runs. And it runs in a sandbox for security. Krill uses firejail when it's installed, a read-only file system, a memory cap, a hard 30-second timeout. Your own code fenced in. And a data point to store the result, wired to watch the Lambda. There's the last arc. The same script could give the wet bulb, the dew point, or the vapor pressure deficit, the numbers a greenhouse lives and dies by. Now that everything's wired, watch the connection arcs. Temperature and humidity feeding the Lambda feeding the wet bulb. There's the pipeline, end to end. No loop, no controller, nobody calling anybody in order, just observers wired together. Let's get in close and turn it on. On its first run, the Lambda reads the two sensors and computes the wet bulb, about 79 degrees from 85 and 76%. There it is in the result point. Now a live reading. The temperature climbs to 88, and the instant it lands, watch the Lambda light up and fire. The sensor changed, so the script runs. Then the humidity updates to 80. The script runs again with both fresh readings, and the wet bulb climbs to about 83. That gap from the thermometer on the wall is what a plant actually feels, as fresh as the data, and the behavior just falls out of the wiring. That's a Krill Lambda. A sensor changes, your Python runs in its sandbox, and the answer flows on to whoever's watching. The whole greenhouse brain, temperature, humidity, wet bulb, and the relays that act on them lives on one little box on the shelf and keeps working even when the internet doesn't.